To the next lesson, linear inequalities on the TI Nspire. This is just a quick one-page lesson where you get to learn really neat tricks for graphing inequality regions on your TI Nspire. It's really nice. So suppose you're asked to graph the region defined by all these inequalities at once. So x is greater than or equal to 0. By the way, if you don't have it ready, get your TI Nspire out now. Okay, so x is greater than or equal to 0. So basically the line x equals 0, but the region required would be x is greater than or equal to 0. 5x minus 2y is less than or equal to 7. And the other equality, negative y, is greater than x minus 3. First of all, things just out of interest for review's sake, which one of these would be a solid line? Have a look at those three. That's right, two of these. These two would be a solid line because they're including that line. The region includes that line. And this one would be a dotted line because that one does not include the line y equals x minus 3. So imagine if you're asked to graph those. In previous lessons you learned just how to graph those, no problem. But imagine if it was a calculator paper. You could also use your TI Nspire to check your answers are correct. So imagine you graphed them, you worked out where the required region was, and you label it R. How could you quickly check your answer using this neat little application on TI Nspire? So watch the video, basically this video that you're watching now for the lesson, for a demo of how to do this and record the TI Nspire instructions below. You'll notice later on I'm also going to ask you to just do a rough sketch of the answer as well, just for memory's sake. Might be a helpful reference to look back on when you're reading through your notes. So make sure to write little instructions for how you did this. So Sierra has taught me a cool little way to do it, which is much better than what I've seen by looking elsewhere. I might just need to make this a little bit smaller so you can sort of see it on your video screen. Yeah. Okay, trying to make it a bit smaller. It won't go smaller. Ah, there it is. I just want you to be able to see the X buttons that I'm pressing down below. Am I going to have to close and open it again? Potentially. Trying to make it come back. Okay. Radio, so I basically just paused and reopened the thing. So what I wanted you to mainly be able to see was to make sure you could see the X and Y and Z buttons down below, because I'll be pressing those so you can actually see what I'm pressing. So we're going to graph all three inequality regions. It's fine even if it just asked you to graph one region, this is still a really neat way to do it using a graphing calculator. If it's a non-calculator paper, you can't use this, but if it's a graphing calculator paper, you can use it. So first thing, of course, however you go to open a graph, you might go to New Document and select Graph. That's one way, Add Graphs. Or you could just go to the Graph application down here. So what's neat, this is the cool thing. So see, it's forcing you to do it fx equals, like y equals. We can unforce it, and we can then, rather than have to rearrange these to make them y equals, for example, x is greater than or equal to 0, it's not even possible to put it in the form of y equals. But we can force the calculator to allow us to type them in exactly as you see them, which is so much better. So once you've kind of got the little function up here, click delete. Select whichever one you want, doesn't matter, select the first one. And see this comes up down the bottom. And then what you can do is you can delete and you can just start from the beginning. So the first one we're going to enter in is x is greater than or equal to 0. So once you've cleared that off, just go to x is greater than or equal to, see the equal sign, you need to go control equals, and then you get some options, and we want to select greater than or equal to, so this one here. So select that, and 0. And because we're going to enter in some other ones, I'm just going to click down, because see, like it up. So what it's done is it's graphed the line x equals 0 as a solid line. The line x equals 0 has been graphed, and it's greater x values that are greater than 0. So this is the region. So the graphing calculator shades the region that is actually the R. So this, if it was just graphing this, you would graph that line, and this would be your R. That makes sense. The line x equals 0 is a vertical line through x equals 0. Now let's enter this one. 5x minus 2y is less than or equal to 7. So same thing here. If you'd by accident clicked out of here, it's fine. You just click back and it opens up again. Double click. So now let's enter the next one. And if you'd made a mistake with this one, I keep going back to what I'm doing. If you made a mistake with that one, click on the label and it'll take you back. But we didn't make a mistake, so just click out here and we're there. 5x minus 2y is less than or equal to 7. 5x minus 2y, control equals, is less than or equal to 7. That's this one here. Have a look at what you've typed. Does it make sense? 5x minus 2y is less than or equal to 7. You could press the down arrow, you can press enter. Down arrow just keeps this up. If you pressed enter, you would just see it. Again, if you made a mistake, you could move your little cursor thing so that you're here. Double click on there, it would open it again. But it's cool. So what it's done is, remember the blue one was what we saw before, and then now it's just graphed the line. 5x minus 2y equals 7 is this line here. And notice it's a solid line as well. Like that one's a solid line, that's a solid line, because these are including those lines. And the region for just this one is all to the left of here, which makes sense. And if it was just these two graphs and you wanted to say what is the region bound by both of those inequalities, it's the part that's been shaded twice. So the part that's been shaded twice would be R. But this question is asking us what is the region that satisfies all three of these inequalities. So we've got to graph this one too. And the region that's been overlapped, that's been shaded in 3 times, will end up being the region that is R. So let's enter in another one. Remember, if you've lost the little screen, you can just double click somewhere. Don't click on the equations because that'll open those equations again. To do a new one, you just double click somewhere else. So negative y, so negative button, y is control equals greater than. So just a simple greater than, that's the first one right here. So just a greater than x minus 3. Just double check, y is greater than x minus 3. Brilliant. Okay, cool. So the line negative y equals x minus 3 is this one here. Does that make sense? If negative y equals x minus 3, then y would equal negative x plus 3. So a negative gradient and a y-intercept of 3. So, and it's saying, and again, if you divided both sides by -1, the inequality sign would flip. And so that's why it's a region that's below. So it does make sense. So your answer is basically you would have to have graphed that line, and this line and labeled them. And the region that satisfies all of 3 inequalities is the region that's been shaded 3 times. So have a look, which region do you think has been shaded 3 times? And that's correct, it would be this region here. And by the way, what do you notice about this line here? If you click on this one, it's solid. Click, hover around this one, solid. You hover around this one, sorry, this line we've just done, it's dashed. So it's dashed because it's greater than. So just I forgot to point that out. So that's really cool. So the region that satisfies all of these inequalities, you've probably seen it, it's this little triangular region here. So you would not necessarily have to shade, but you would have to kind of like draw the lines and mark in this region here with an R. I'm going to take a little snip of that if it's going to let me, because it asks you to do a sketch below, and I'm not on the smartboard, I'm just on the freehand computer, so it's a bit of a dodgy sketch, but it'll do for now. So you pause and write your instructions as you go. You might want to pause and review this, particularly like how do you get to be able to type in the equation, like how do you kind of, remember you press delete and then select any of the ones on offer. So what do I mean by that? So imagine we'll go to a new one, graph. So you would go delete, select any of the ones on offer, doesn't matter which one, it opens up, and just delete it off and start from scratch. So that's really neat, the fact that you can do that on these calculators. So handy. You can just type them in exactly as you see them. You're not forced to rearrange them to make them into y equals. Same as when you're doing any kind of graph on the TI Nspire. It's a really neat feature. So you pause and write your instructions. Also include a rough sketch of the answer that you see. I would say you practice doing a little sketch. In this case, I'll just make it a bit bigger so we can see it. And remember, we need to mark in the region. That's our answer. So this is the region. That's our answer. It's this one. That's here. That's our region. Yeah, cool. So hopefully that's illuminated how, or demystified how you use the TI Nspire to graph regions of inequalities. So thank you to Sierra for pointing out the way to be able to enter the equation in the way you see it on the page without having to rearrange it to make it in the form of y equals first. Okay, thank you.